Hello, everyone. This is Belinda Carr, and you're listening to my podcast on building products and technology. As we know, the construction industry is ripe for automation and disruption. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with Mohsen Zehtabchian, COO and co-founder of Amatec. Thanks for joining us, Mohsen.
Absolutely happy to be here, Belinda.
So I came across you and your co-founder and your company, Amatec, through LinkedIn recently because y'all published an article on your new product. Y'all are calling it high density gypsum, or HDG. And you've made some pretty bold claims on your website. And I'm very interested in diving more into the product itself because it seems like it has a lot of potential and could be a strong alternative to concrete, wood, ceramic, and steel. And on one of the claims that y'all have made is that y'all can use HDG to build houses cheaper, faster, and more eco-friendly than any competitor in the market today, which is pretty incredible. And of course, I'd love to dive more into that. But before we do, let's talk about you. What's your background? How did you get into this industry with your co-founder, Igor?
This is actually a very interesting question, and one that I actually think about from time to time and try to think of a way to properly answer this, because it happened completely by accident. So I'm currently in my last year of university. I'm currently also doing my exchange right now in Spain. So I guess you could say I'm currently based in Spain right now, but I'm mainly based out of Canada. So there's that. And I am a business student. So I'm currently majoring in finance. And to be quite honest with you, ever since probably high school, I always knew that I would be in business, but I never really knew what kind of business I would be. And because I didn't know what type of entrepreneur I wanted to be, I always kind of thought that, maybe right after university for a few years, I would potentially work at a normal corporation, get some experience. And that's what I essentially did for the past 8 months. I worked at a bank as a financial analyst for a co-op term. And so I kind of just saw myself being within the financial world for a little bit and then maybe figuring out from there. But one interesting thing happened approximately like 8 to 9 months ago. I would say it was October 2021. And my mother had to go to her home country of Russia to, just to fill out a few documents that she just had to do. And I also had to file for an internal passport. It's something that they do in Russia, and I had to do since the age of 14, but I never got around to doing. And then when I went there, my dad was like, "Oh, Mohsen, by the way, one of my closest friends and former business partners in the 90s, he's in Moscow right now. Why don't you go and meet him and talk to him and just hear from his perspective what we did together?" And I was like, "Okay, I'll see if that can happen." And then my dad actually called his former business partner, which is Igor Stavrilov, the CEO of Amatec. And I went out of my way one morning at 7 a.m. Igor's an early bird, I'm going to tell you that. And I went and met him at some convention outside of Moscow. And we just sat down and had some coffee, and he told me about what he was doing. That was one of the topics of conversation that we had. And what he was doing sounded really interesting to me, because I was like, this is definitely not something this is like, I've spoken to many entrepreneurs, and almost all of their inventions and products, they could be cool, but they didn't sound as disruptive as what I heard Igor tell me.
And he was telling you about this HDG, high density gypsum, that he has been developing over the last couple of years.
Yes, and he spoke to me in baby terms, essentially, because I essentially started speaking with him about, HDG with practically no knowledge about anything about the construction industry. I barely knew anything. I didn't know how concrete was even made. I'm going to be honest with you. And then once he explained it to me, we had a good 2-hour conversation. And then by the end of it, I was like, okay, this is actually kind of insane. And then I went home, didn't really do anything about it. I kind of just thought, and I was like, okay, is there any way I could potentially be a part of this? Because if I can be, one of my goals in life is to be a part of something massive. And I thought that this potentially could be the one thing that could help me achieve that. And I maybe 2 to 3 weeks later, I reached out to Igor before I was flying back to Canada. And I was like, okay, Igor, is there any way I could potentially help you? I'm going back to Canada. Do you want me to show this product to anyone or whatnot? And he was like, sure. He gave me a few samples. And then he kind of just saw my interest in, the startup. And he, maybe a few weeks later, he welcomed me on board. I'll just put it that way.
Oh, that's nice. But he's basically the brains behind the company. He's developed the product and you're
completely. I initially saw myself as an assistant, but now I envision myself as someone who's pushing the company forward, because there are a lot of limitations on Igor's side with regards to making this company global. And
has he been marketing the product in Russia or in Eastern Europe?
To a degree, yes. His ultimate goal was always to enter the US market. But he did, market the product here and there, and he did get a lot of interest, but he never chose to stay in the Russian market and just pursue building the company there, because he sees more potential in scalability and growth in
the States. Yeah.
And from the States, you can actually it's much easier to expand globally as opposed to expanding from Russia, of course. So there was that as well.
So I've went through your website before this call, and there's very interesting history behind HTG, and especially him coming from Eastern Europe and Russia. This makes sense because the material was used in that country for a long period of time, and it's proven to be a long-lasting, resilient product.
That's correct. So just to be a little more specific, HTG itself wasn't used in that region. It was variations of gypsum. So I'll be happy to give you a rundown of the history of gypsum technologies that were used in the USSR. So in the 1940s, the USSR began to implement this technology called autoclave gypsum or alpha gypsum that really helped them build a bunch of buildings very quickly and in abundance, because of course, as you may already know, in a communist state like the USSR, one of their goals was to build millions and millions of houses in a very quick span, simply because the state was responsible for housing its citizens.
Yeah.
So gypsum happened to be the great material for that, and they essentially started building with something called alpha gypsum, which was strong enough to serve as a basic building material for their purposes. And just to
what was the reason behind using that as opposed to concrete? Was concrete not as easily available?
See, that is actually a very easy question, one that I think about quite often. I don't have a direct answer for you as to why they didn't use concrete as much as they use gypsum for building buildings. But I do suspect that it is mainly because with concrete, it takes much longer to build, especially with the curing time and all of that. But with gypsum, it's actually much more simple to build with. Okay. And especially when they had to build millions and millions of apartments, that helped them.
The better material to use.
Yeah, and just to give a little bit more of a background, gypsum is not known to be a strong material by any stretch of the imaginations. For your viewers that don't know about gypsum is a very common natural mineral in nature, and it's mainly used to produce products like plasterboard and drywall, which are not very strong products, of course. But the interesting thing is that, gypsum is actually very strong in nature, but it is following the calcination process where gypsum loses the majority of its strength and durability. And that is why we don't build skyscrapers out of gypsum today. And also another thing is that gypsum loses a lot of roughly over 2/3 of its strength when it is exposed to vapor and water. So that is another reason why we don't really build from gypsum today. So, but the USSR, essentially what they used was something called autoclaved gypsum.
That's what you said, autoclave. So that means it was baked in a factory in controlled environments and then brought to the job site, like an early form of prefab, early form of modular construction.
In some sense, yes. So I believe the calcination process is a little bit different for alpha gypsum as opposed to normal gypsum, or I believe that's also called beta gypsum for normal gypsum. And it was strong enough where even though gypsum, that very same gypsum lost 2/3 of its strength upon exposure to water, vapor, and just water, it was still strong enough where it was able to still hold a building together. And we can say that that is true because those very same buildings that were built in the USSR in the 1940s are still standing today, and lots and lots of people are still living in them. And that was essentially the first generation of gypsum technologies of the USSR. The second generation of gypsum technologies were essentially developed in the 1970s, and that is when they introduced cement to gypsum in order to preserve gypsum strength even in the wet state.
Okay. And this was also developed in the USSR?
I believe so, yes.
Okay.
This was developed in the USSR. And the one thing though is that we don't mix gypsum and cement today because it produces something called ettringite, I believe, if I'm pronouncing that correctly. And ettringite increases in volume and it creates, and it causes destruction. Okay. And that's a challenge when you mix cement and gypsum. But what these USSR scientists did is they found a third component that they were able to add into this composite where that
neutralized that.
Yeah, the ettringite. So it no longer was being formed. And that was a second generation of gypsum technologies where they were able to preserve the strength even in the wet state. And then there was the third generation of gypsum technologies that was pretty much developed in the final years of the USSR. And that is when the world started using plasticizers to reduce water consumption within certain composites. And the USSR began doing the same to not use as much water. And if you use less water for gypsum, its density actually is greater and the material is even stronger. So that was like, I guess, the first stage, I would say, of high density gypsum technologies.
Okay.
And, eventually the USSR collapsed and a bunch of industries collapsed in the country. And and gypsum was pretty much no longer used. All these other Western companies came into Russia, I guess, Ukraine, Belarus, Kazakhstan, and they started building with concrete their own ways. So that type of building was pretty much abandoned. Yeah. And but the beauty of it is that all these buildings are still being lived in today. They still exist. They're still very safe, and especially those ones that were built in the 1940s. So that essentially shows to us that gypsum can be a basic building material. And
so now your co-founder or CEO, Igor, has basically invented the fourth generation of gypsum.
We never called it that, but you can say that, I guess. That's actually quite interesting. So I guess, yes, Amatec or Igor developed the fourth generation of gypsum technologies. So I guess we could say it's the evolution of what was already developed in the USSR. And essentially what high density gypsum technologies is Igor, our CEO, figured out how to significantly increase the density of gypsum to the point where there no longer needs to be any additional additives placed into any sort of composite of gypsum.
And there's no cement added into it either?
No cement, absolutely. None of those are needed within high density gypsum because it is so dense where water no longer penetrates into the gypsum. So there no longer needs to be any of that to protect the gypsum from water and I guess all of that. And another thing is that the denser gypsum is, the stronger it is. And just to give you a little bit of a perspective of how strong high density gypsum is, in compression, it can be roughly twice as strong as ordinary concrete. So, ordinary concrete can be pretty much anywhere from 20 to 45 megapascals in compressive strength. High density gypsum ranges anywhere from 50 to 110 megapascals in compression. And also in terms of flexural or bending strength, I believe ordinary concrete is somewhere between 3 to 6 megapascals in strength. High density gypsum ranges from 12 to 17 megapascals in bending strength. So it can be roughly 3 to 5 times as strong as ordinary concrete as well. So it is actually a very, very strong material. So that is one thing.
That's fascinating.
Yeah.
So has Amatec made large panels of these HDGs, or have you all tested just on small panels up to now?
Oh, that's a really good question. So right now, as a company, we're at a stage where in 2021, high density gypsum technology has been fully developed. So right now, the technology is done. Right now, we're in the phase where we want to implement this technology. And I think you're jumping a little bit ahead when you're saying panels, because one thing that we want to mention to your audience is that we want to use this technology to produce houses, because we believe that this technology is best fitted for this industry and it will scale and grow more quicker here than anywhere else. And to be more specific, we want to build prefab houses out of this technology from a new way of building. Of course, when your material goes from liquid to stone within 20 minutes, that opens up to a complete new way to construct. You no longer need to construct like the way you construct with wood or concrete, because they have their own properties where you have to construct around them, around their limitations. Yeah. But we have this is a complete new material. So there's a new way that you can construct with. And we developed our own way to do so.
So before, you just talked about the 20-minute curing time, which is pretty amazing. Can you do that on job sites, or does that have to be in controlled environments in a factory? Like, do these panels have to be made in a factory and then transported?
So it can be done on job sites, it can be done in a factory, but it's best to do it in a factory because of the optimal way to build using high density gypsum technologies for houses is in a controlled factory to create prefabricated panels. And so far, we didn't build a 3 meter by 5 meter panel, because we don't need to do that, especially when we haven't built our very first house yet. But we did create these small models and prototypes of what those panels could look like. I wish my fellow co-founder was in this call, but he couldn't make it but just to give a little bit of a verbal explanation of what that panel looks like, is that the interior portion of the panel is aerated high density gypsum, which essentially is a mixture of high density gypsum with air. And the reason we do that is because we found out that it has superior thermal properties.
Absolutely, yeah, because you're basically trapping air inside the panel. That's interesting. So that's sandwiched between two more structural forms of HDG.
Yeah, so pure high density gypsum. And we actually, you might be thinking we just want to create the mixture and then make it like a block and then pour raw high density gypsum over it. It will actually be a little bit different than that. We actually want to create standardized elements. It's quite difficult to verbally explain it. It's something that it took me like a few hours to understand. So I'm not going to go into too much details of it, but we essentially want to change the way we construct homes in a prefabricated manner. And we want to create these standardized elements that can be produced very quickly, and then use them and put them together to create a customizable wall. That can't really be done with any other technology today because it's simply unfeasible. If you want to do that with concrete, go wait 12 hours for your aerated mixture to essentially dry, and then you pour raw concrete over it and wait 12 hours and you turn it around and do the same. That's not very feasible. So this is something that's feasible with high density gypsum technologies. So
it sounds like you're making these building panels that have insulation in the middle of the wall, are
Mm.
structural on the outside, and they serve as a finished surface both on the inside and the outside because they are waterproof and probably
Yes,
fireproof too because they made of gypsum.
100%.
They have
Yes.
no paper-based finishes, like no paper base on the inside or the outside. It's just exposed gypsum.
Yes, exactly.
That's pretty awesome. And how large do you envision these panels, or how thick do you envision these panels being?
It really depends. For example, an exterior panel, it would obviously be a little bit thicker to protect the house against, let's say, a hurricane or any form of natural catastrophe. But for interior panels, it would probably be a little bit less. And it really depends on what R value you're trying to get. Every state has its different sorts of regulations around what certain R values have to be. And we would essentially make the thickness in such a way that satisfies every state regulation. I guess that's the easiest way to put it.
So I guess we've covered how it's faster than concrete, stronger, more eco-friendly because you aren't having to heat it up in a kiln to cure it.
More than that, actually. It's eco-friendly for more than that, actually. So, well, for one, high-density gypsum it has so its carbon footprint is roughly 3 times lower than that of concrete. That's one. But that's not even the strongest point with regards to eco-friendly. We don't advertise it as much simply because we believe that in the nearest future, there will be low carbon concretes. That's something that is already being developed. What we advertise more about high density gypsum is that it is 100% recyclable in the sense that you can reuse it for the very same purpose indefinitely. And no one really talks about that because you look at all these buildings and houses around you and no one really says what's going to happen to all of this. Most of it's going to end up as waste.
Landfill, yes.
Yeah, some people talk about it, but not enough people talk about it. And what's terrible about that is that the construction industry is continuing to construct in such a way where we're continuing to produce buildings and houses that will end up as waste.
Yeah.
And that's awful. But with high density gypsum, that is not a concern. That is our big, strongest point with regards to eco-friendliness.
So is there no rebar included in the panel? There's no rebar needed?
Nope, not for houses. If you want to build if you hypothetically want to build like a skyscraper out of high density gypsum, yes, you would have to use a rebar, and you can do it very, very easily. So there's no concern with regards to that.
So when you talk about it being infinitely recyclable, you say that once, if you are demolishing a house, break it down into its powdered form and then
reuse
process, how would you do that? Is it heated up? Is it mixed with water? Is that just a proprietary technique you can't reveal?
Well, I'm not so much on the technical side, but I do believe the answer to that would be you would just do so when we get calcined gypsum from the market, and then when we create high density gypsum out of it, let's say, we would just treat that powder as potentially calcined gypsum.
Okay.
So you would just redo the whole process again, but
there's very minimal chemical reactions involved in the creation of HDG from raw gypsum, which is why you can recycle it.
Yes, you can recycle it 100%. So that's the good point.
That makes sense. Okay, so let's talk about the last advantage, it being cheaper than all the other alternatives out there right now. How are you able to make this much cheaper than concrete, wood, cement, ceramic and steel?
So I guess this is a question that involves a lot of thought. So I guess on a metric basis, high density gypsum costs roughly the same as concrete. So it's roughly $40 per ton. And that includes the cost of the purchase of the raw gypsum. However, the reason why we say it's cheaper than, let's say, concrete, for example, is that because it is so much stronger than concrete and because its density is a little bit lower, you can effectively use less material to perform the very same task. So there's this aspect of high density gypsum. But where the main reason why we say it's cheaper is that because it has such a fast curing rate, has no shrinkage induced deformations and none of that, you can significantly automate the production process of not only the material, but panels as well, to create these houses. And we suspect that we can pretty much reduce the carbon footprint of the average house at least by half if we use high density gypsum.
So what are the future plans for Amatec? When are you all going to be able to scale up and actually produce large panels for this product?
So right now we're at the stage where we are preparing to undertake a pilot project where we want to build our very first gypsum house, and our production facility of those panels to make that gypsum house. And but right now what we're trying to do is raise our first $1.5 million to make all of that happen. And then once we produce our gypsum house, we will begin our second round of funding, where we essentially will aim to scale the production process, production capabilities of high density.
That's very exciting.
So hopefully by the end of 2023,
okay.
I will see that.
We'll definitely look out for some news articles, and we'll definitely keep in touch. And yeah, so I have to ask you a question. Just this is outside Amatec, outside HDG.
Sure.
You're a pretty inspirational person. You've identified this technology that Igor has developed as something that has a lot of potential to change the construction industry. And you didn't wait to graduate to jump on this opportunity. What advice would you give to other college students out there who are interested in starting their own venture or maybe teaming up with some companies?
My advice to students my age is, you are young enough where, if you undertake an entrepreneurship venture, and let's say you fail, what is the worst thing that could happen? Nothing. You still have your whole life ahead of you. So use these moments now to learn as much as you could, to take as many risks as you can. And obviously, weigh the risks. If you don't have a really great idea, if you don't have a really great product, then maybe that corporate job for the next few years might be a good idea, but who am I to tell you what to do, of course. But don't be afraid to take risks if you see a very great outcome at the end of it. So that was my logic behind it. And I think that every young person should have this very same outlook on life.
That's so inspirational. And I have to ask you, has it been frustrating or difficult to get people to take you seriously just because older people are so dismissive of younger people?
Absolutely, especially in the construction industry. Almost every professional that I speak to is at least twice my age. So typically,
what do you know about cement? What do you know about gypsum?
Exactly. That is a very fair point, and I don't even blame them for thinking this way. So one way I generally tend to avoid this is, anytime I go into a meeting with any sort of professional or whatnot, I always bring Igor with me, so they know that there is an actual, a scientist in the room that has experience within the construction industry that's longer than I've been alive. So that's one way I tend to overcome this. The other way is just to be confident in yourself and just know what you're talking about and understand what others are saying. And generally, when you talk in a way and when you present facts in such a way where they're accurate, or at least if people understand you, age is generally not a problem. So
that's very, very good advice. Yeah. Oh, thank you so much
Absolutely.
for sharing all that. And again, I'm looking forward to seeing your company and your products scale up. And maybe we can talk to Igor soon and
Absolutely.
ask him, dive into some more specifics about the product.
Absolutely. We'd be more than happy to do that.
Thank you, Mohsen. Good luck with everything.
Thank you so much, Belinda.